Namaste, Vanakkam, and a warm welcome back to you to Medha Guru. It's me, Manan, the maths teacher here. So today we are going to cover the chapter, that's chapter 6 in the textbook Selina, that is word problems on quadratic equation. And we'll see how to solve word problems. So in this video, we'll be seeing how to form equations from given word problems. Now these word problems may be of different types. The first type will be related to numbers and also work and time. The second type will be related to geometric figures like triangles, rectangles, their diagonals. The third type will be that of speed and time, that is speed, time and distance related word problems. Then there will be miscellaneous problems like related to profit and loss, sale of items, discounts and whatnot. So without further ado, let's get into the lesson. So before we get into how to solve quadratic equations, that is word problems on quadratic equation, the first step should be to try and understand how to form equations from the given statements in these word problems. See, if we have studied quadratic equations the chapter properly, solving these equations is not going to be a tough time. The tough part is forming these equations from the given statements. So we'll see these different types of word problems one by one, and we'll see how to form equations from these given word problems. Okay, so the first type is that related to numbers or work and time. The question here says 5 times a certain whole number is equal to 3 less than twice the square of the number. Let us see what we can deduce from this. Just a second. So we don't know the number, right? So the first part is we'll take the number to be x. Now it says 5 times a certain whole number. So 5 times we know is 5 into the number that is x is equal to, so we write equal to 3 less than twice the square of the number. So it says 3 less than, so we'll write minus 3. And then it says twice the square. So twice the square of the number would be x squared. So from here we can say that it is 5x is equal to 2x square minus 3. And then we'll bring all the terms to one side, then we'll get 2x square minus 5x minus 3 is equal to 0. So this is how we will form equations from the given word problems. Let's see a few more examples, okay? So in this next example, it says that the sum of two natural numbers is 8 and the difference of the reciprocals is 2 by 15. So we'll take the two natural numbers to be x and 8 minus x, since the sum is equal to 8. Now it says their reciprocals. So the reciprocals of these numbers will be 1 by x and 1 by 8 minus x. Now since it says the difference, let us consider one of them. Let's say 1 by x is greater than 1 by 8 minus x. So we will say 1 by x minus 1 by 8 minus x is equal to 2 by 15. This is the detail that the statement is giving us, or the word problem is giving us. Now from here what we will do is we will take the LCM, it is x into 8 minus x. Then here 1 is multiplied to 8 minus x and this part is multiplied to x. Then we have 2 by 15. So it will be equal to 8 minus 2x by 8x minus x square, which is equal to 2 by 15. Now we will multiply this 15 up to 8 minus 2x and we'll bring 8x minus x square up to this side. So we'll get 15 times 8 minus 2x and twice of 8x minus x squared. Oh, sorry, 8 minus x squared. So now we have 120 minus 30x. Oh, this is 8x. Sorry, it's 16x minus 2x squared. So now what we do is we bring all the terms to one side. We get 2x squared minus 46x plus 120 is equal to 0. If we divide the entire equation by 2, we get x square minus 23x plus 60 is equal to 0. So this is how we can form equations given from word problems that are based on number theory, that is numbers related to each other. Now let us try and see an example of a word problem that is based on work and time. So now we have an example of problems related to work and time. In such examples or in such problems, we'll have, for example, let's read the problem on the board. It says for the same amount of work, A takes 6 hours less than B. If together they complete the work in 13 hours 20 minutes, find how much time will B alone take to complete the work. So we need to understand that such problems can be solved with the logic that we will calculate how much work each of them does in one day. And then we'll compare it to how much they both can do in one day. I'll show you how. So before we begin, there are a few statements we need to write to arrive at this equation. So now we'll treat this the complete work as one unit of work. So let's say to complete the work, A takes, let's say, X hours. So now if this work that is written here is 1 unit, we can say to complete, and I'll divide both sides, this side and this side, by X. So we'll say 1 by X of the work, A takes 1 hour. Now similarly, to complete the work, B takes, now since the question says that A takes 6 hours less, it means B takes 6 hours more. So we'll write X plus 6. Now again, treating the work as a single unit, we'll write to complete 1 by X plus 6 of the work, B takes 1 hour. So this is how much both of them can do in 1 hour. That is, A can complete 1 by X of the work in an hour and B can complete 1 by X plus 6. Now let's see what they can do together. So to complete the work, both take, now see, this time is given in 13 hours 20 minutes. We'll just convert it to 1 hour, 1 unit, that is hours. So we'll write 13 and 20 by 60 will be 1 by 3. So 13 1 by 3 hours, which is nothing but 40 by 3 hours. So they can complete, again treating the work as 1 unit, they can complete, since I'll do 1 by 40 by 3 and it will become the reciprocal, 3 by 40 of the work in 1 hour. Now we have all the details of how much A can do in 1 hour, B can do in 1 hour, and what both of them can do in 1 hour together. So we'll just add both of them, which means that 1 by X is what the work A does in 1 hour, plus 1 by X plus 6, what work B does in 1 hour, is equal to 3 by 40, since both of them complete this much of the work. So now we'll take the LCM here, it will be X into X plus 6, and up we'll multiply X plus 6 here to 1 and here X, then it will be equal to 3 by 40. So we can write this as 2x plus 6 by x square plus 6x is equal to 3 by 40. Now we'll just cross multiply 40 to 2x plus 6 and x square plus 6x to 3. So we will get 80x plus 240 is equal to 3x square plus 18x. Bringing all these terms to one side, we will get 3x squared minus 62x minus 240 is equal to 0. So this is how we will form equations based off of problems that are based on number theory or work and time related problems. So now that we have got a fair idea of this concept, let's try and solve a few example problems based on these logics. Now let's try solving a few problems based on numbers and work and time. It says divide 20 into 2 parts such that 3 times the square of one part exceeds the other part by 10. So here simply we'll take 2 parts as x and 20 minus x. Since both these parts are added, give us 20. Now based off the question, it says that 3 times the square of one part. Let us take the square of one part and multiply 3 to it. So 3x square of one part exceeds the other part by 10. Now the other part is 20 minus x and this exceeds it by 10. So we add 10. Now when we form the equation, we get 30 minus x. We bring it all to one side, we get 3x square plus x minus 30 is equal to 0. Now we'll go about by solving this equation. Now we can solve this equation by two methods, that is factorization or by the quadratic formula. And if you don't know how to solve by these methods, it means you haven't watched the basic concept ideas of quadratic equations and the exercise solving part. So please go to our channel Midha Guru down in the description and watch both those videos to get a better grasp of this chapter. Apart from that, our channel Midha Guru has teachers of the highest quality of subjects like SST, science, and even English. So please subscribe to our channel and join the family today. Coming back to our problem, now we have 3x squared plus x minus 30. So to solve this dilemma, we have to do that we'll multiply a, that is ax squared plus bx plus c. In that form, we'll multiply a to c. We'll see 3 into minus 30 will be minus 90. And so we have to split our middle term, that is b, into such that the coefficients multiply to 90, minus 90, and add to 1. So we'll write 3x squared plus 10x minus 9x minus 30. So we'll see that plus 10x minus 9x gives us x, and when we multiply plus 10 into minus 9, we get minus 90. So here, since we can't take anything except x as common, we take x, we get 3x plus 10. And then here, we'll take minus 3 as common. We can again get 3x plus 10. So now, taking 3x plus 10 as common, we'll get x minus 3 is equal to 0. Following the zero product rule, this would mean that either 3x plus 10 is equal to 0 or x minus 3 is equal to 0. From this, we'll get that x is either equal to minus 10 by 3 or x is equal to 3. Now here in word problems, since quadratic equation will always have two solutions, we have to see which qualifies the best for our given word problem. It says you have to divide 20 into two parts. That means they should be whole numbers. It's not given in the question, but it's logically understood. So we'll see that minus 10 by 3, it cannot be a part of this question. So we'll say that this is the correct answer. So the two parts in which we can divide this number 20 into is 3 and 17 by satisfying that was given in the statement. You want to check? We'll see it says that 3 times the square of one part. Let's take the square of 3. So 3 times the square of 3 will be equal to the second part, that is 17, increased by 10. We know that 3 squared is 9. So 3 into 9, and this side is 27. And we'll see 3 into 9 is also 27. And since this condition is satisfied, we can say that this is the correct answer. So now moving on to the next question, we have divide 15 into two parts such that the sum of their reciprocals is 3 by 10. The question is quite similar, but it's a bit of a twist. Now we'll see. Again, we'll divide the number into x and 15 minus x. Since x plus 15 minus x will give us 15. Now it says their reciprocals. So we should take the reciprocals of these numbers first. So the reciprocal of x will be 1 by x, and that of 15 minus x will be 1 by 15 minus x. Now the question says that the sum of these reciprocals is equal to 3 by 10. So now we'll take the LCM of this and this, we'll get x into 15 minus x. So up above we get 15 minus x multiplied to this, and next to this we get plus x is equal to 3 by 10. Now we can cancel out the x. Since nothing is left, we can cut 3 into 15 by 5 times. So now we multiply 10 up here and we take this to the other side. We get 50 is equal to 15x minus x squared. Again, we bring all the terms to one side. So we get x squared minus 15x plus 50 is equal to 0. Now again, I will solve this by factorization. So I have to split minus 15 into such that the add up to minus 15 and the coefficients multiply to 1 into 50, that is plus 50. So I'll write 5x minus 10x plus 50 is equal to 0. So I'll take x out as common, and I'll get x minus 5, and here I'll take minus 10 as common. So again, I'll get x minus 5. So x minus 5 into x minus 10 is equal to 0, which means that either x minus 5 is equal to 0 or x minus 10 is equal to 0, which means x is either equal to 5 or x is equal to 10. Now here in this, we got two solutions such that they are both whole numbers. So what do we do? But here in this question, if you apply the value of x to this particular, where we got that the two parts are x and 15 minus x, we'll always get 5 and 10 itself. If we take x as 5, we get x is equal to 5 and 15 minus x is equal to 10. The other way around, if we take x as 10, this becomes 10 and this becomes 5. So the numbers will be 5 and 10 itself. Let us see one more example. So it says 3 consecutive natural numbers are such that the square of the middle number exceeds the difference of the squares of the other two by 60. Lots going on here. So let's see. It says 3 consecutive natural numbers. You may have been told to take it as x minus 1, x and x plus 1. However, we can take it any way we like. I want to take it as x, x plus 1 and x plus 2. These are our 3 natural numbers. Now it says the square of the middle number. Now the middle number here is x plus 1. We'll say x plus 1, as it says square, square exceeds, it says exceeds by 60, so we write plus 60 first and foremost. Then it says the difference of the squares of the other two. We have to take the difference of the squares of these two numbers. But here it is to understand that since x plus 2 is larger than x, its square will also be larger. So we'll take x plus 2 squared minus x squared, since it says the difference of the squares. Now we will go about by solving. So x plus 1 whole squared will be a square plus b square plus 2ab. Again, a plus b whole square is a square plus b square plus 2ab minus x square plus 60. Now the x square and x square get cancelled. So we have x square plus 2x plus 1 is equal to 64 plus 4x. Again, we bring all to one side of the equation. We get x square, since this comes here, it becomes minus 2x, and 64 comes here, it becomes minus 63. Now again, I have to factorize by splitting minus to such that we get a product of minus 63 and a sum of minus 2. So we'll write x square minus 9x plus 7x minus 63 is equal to 0. Since minus 9 into plus 7 is minus 63 and minus 9 plus 7 is minus 2. So I'll take x as common, I'll get x minus 9. Then I'll take 7 as common, again I'll get x minus 9. So x minus 9 into x plus 7 is equal to 0. From here we can say that x minus 9 is equal to 0 or x plus 7 is equal to 0. So x will be equal to 9 or x will be equal to minus 7. Again, we have two values for the variable. But our question very clearly mentions natural numbers. And since we know minus 7 is not a natural number, it's an integer. So we'll take the value 9. So the three numbers will be 9, that is x, x plus 1, that is 10, and x plus 2, which is 11. So these will be our three consecutive natural numbers which satisfy the given condition. Now let us see one example related to work and time problem. So it says A can do a piece of work in x days and B can do the same work in x plus 16 days. If both working together can do it in 15 days, find x. So we saw an example of how to write an equation, right, from the statement. It was in hours and this is in days. That's the only difference. We'll go about our job just the same. So A can do the work in x days. So let us treat the work as one unit. If we divide both sides by x, we get 1 by x of the work in x by x, which will be 1 day. Similarly, B can do the work in x plus 16 days. So if we take again work to be like a single unit, that is the whole work as one unit, we'll divide it by x plus 16, we'll get x by 16 of the work in x plus 16 by x plus 16, you guessed it, 1 day. Now since A works this much and B works this much, this should give us how much they both can work in 1 day together, right? So we can get that also from this statement here. It says together they can do it in 15 days. So again, we'll say that if we want to treat the work as one unit and divide it by 15, we'll say they can do 1 by 15 in 1 day, which means they're together working, they'll do 1 by 15 of the work. So let's go. So now we'll say x into x plus 16, x plus 16 here plus x, since x plus 16 and x is equal to 1 by 15. So you'll get 2x plus 16 by x square plus 16x is equal to 1 by 15. We'll take this two terms up here and 15 multiplied to this. We'll get 30x plus 240 is equal to x square plus 16x. Now we'll bring all of this to one side. We'll get x square minus 14, since 30 goes that side and becomes minus 14x minus 240 is equal to 0. Again, we'll solve by factorization and get our values for the variable x. We'll get x squared minus 24x plus 10x minus 240. Since minus 24 into plus 10 is minus 240, and adding them we get minus 40. So I take x as common, I get x minus 24. And then I take 10 as common, I get x minus 24 again. So now x minus 24 into x plus 10 is equal to 0. So x is either equal to 24 or x is equal to 10. Sorry, minus 10. Since plus goes and becomes minus. Now, since what we are finding here, the quantity x is in days, it cannot be a negative number. So, answer will be 24. So, A can do the work in 24 days. Now, B can do it in x plus 16. So, we can say that B can do the work in 40 days. So, this is how we will form equations from word problems based on numbers of work and time, and then solve these equations to get our answer. Now, we'll see the next type of problems, that is based on geometric figures. So, now let us see word problems based on geometric or plane figures. So, in this we will have relations based on Pythagoras theorem. Basically, mostly it will be Pythagoras theorem, or else the area of a square or a rectangle related to its sides. So, let's try and understand how the first step, that is we are supposed to form equations from the given statements based on geometric figures. This question right here says the hypotenuse of a right triangle is 13 centimeter and the difference between the other two sides is 7 centimeter. So what we'll do is, oh sorry, I drew a square, I'll make it a triangle, I'm so sorry. So it says that the hypotenuse is 13, so we take this hypotenuse as 13. Now it says this the difference between the other sides is 7. So we'll take one side as x plus 7 and one side as x. Since if I take out the difference, it becomes plus, that is 7 will be left over. So the difference will be 7. So now it says taking x as the length. So I took the shorter side as x and the other side as x plus 7. So when I'll try and solve this, so it says I know the relation of the Pythagoras theorem is h square is equal to p square plus b square, from which h is 13. So 13 squared is equal to the perpendicular is x plus 7. So x plus 7 whole squared and the base is x itself. We will get 169 is equal to x square plus 49 plus 14x plus x square. So I'll bring 169 to this side. I'll get 2x squared plus 14x. So this becomes minus 120 is equal to 0. I divide the whole equation by 2. I get x squared plus 7x minus 60 is equal to 0. So this is how we are supposed to form equations based off of problems based on geometric figures. Let's just see one more example. So now this says the length of a veranda is 3 more than its breadth. The numerical value of its area is equal to the numerical value of its perimeter. Taking x as the breadth of a veranda, write an equation in x that represents the above statement. So it says the length of a veranda is greater than its breadth, which means it's a rectangular veranda. Now if I take the breadth as x, as it says, taking the x as the breadth, it says the length is 3 meter. So I write x plus 3. Excuse me. The second part of the statement is a bit more complex. It says the numerical value of its area is equal to the numerical value. First of all, let us see what the area will be. The area is length into breadth. So x into x plus 3, which you will get as x square plus 3x. And the perimeter is 2 times L plus B. So 2 into x plus 3 plus x. So 2 into 2x, which is 4x, and 2 into 3, which is 6. Now according to the question, these two values are equal numerically. So x square plus 3x should be equal to 4x plus 6. When I bring all to one side to tidy it up, becomes minus x minus 6 is equal to 0. This will be how we will solve or form an equation based off of geometric figures, that is questions based on geometric figures. So let us see a few example problems, try to solve them, try to see what the solutions are for word problems based on geometric figures. The first example problem says the hypotenuse of a right angle triangle is 26 centimeter and the sum of the other two sides is 34 centimeter. Find the length of the sides. First things first, we'll draw a right triangle. So it says the hypotenuse is 26 centimeters and it says the sum of the other two sides is 34. So if we take one side to be x, the other should be 34 minus x, because when we add them, we'll get 34. Now what do? We apply Pythagoras theorem. It says h square is equal to p square plus b square. We know the hypotenuse is 26. So 26 squared is equal to 34 minus x squared plus x squared. So 26 will get as 676 is equal to 34. This will be a minus b whole square, which is 34 squared. 34 squared 1156 plus b squared plus minus 2ab, then x squared. So we bring this 676 to this side, we will get 2x squared minus 68x, and then we will get plus 0 50 minus 8 is equal to 0. Now we'll divide the whole equation by 2. So we'll get x squared minus 34x plus 240 is equal to 0. Think about what we need to do to factorize this. I'll just take a sip of tea. So now we have a is 1 and c is 240. So the product is 240. So we have to divide this minus 34 into 2 coefficients such that the product is plus 240. So I'll write x square minus 24x minus 10x plus 240 is equal to 0. Since minus 24 into minus 10 will give us plus 240, and adding them will get minus 34. So I take x as common, I get x minus 24. And then I take minus 10 as common, I again get x minus 24. So x minus 10 into x minus 24 is equal to 0, which means x is equal to 10 or x is equal to 24. Again, we come at a juncture where we have two variables, like the two variables, the two solutions for the variable are both real and natural numbers. And since we know that the measurements of geometric figures should be positive real natural numbers, if we are looking at it, we may think that 10 may be one answer and 24 may be the other. But if you equate it, if we take x to be 10, this becomes 24. Or if we take x as 24, 34 minus 24 becomes 10. And since we know that the orientation of a right triangle can change, that is the perpendicular can be the base and the base can be the perpendicular, we see that this answer makes a lot of sense. So we'll say the sides are 10 meters, 24 meters and 26 meters. Okay, let's see the next example question. So in the next example question, it says the diagonal of a rectangle is 60 meter more than its shorter side and the larger side is 30 meter more than the shorter side. Find the sides of the rectangle. So first things first, when you read the question, you see both of them link it to this shorter side. That is, this is the diagonal 60 meters more and the longer side is 30 meters more. So we'll take the shorter side to be as x. And in the rectangle, we know the shorter side is the breadth. So now this is the diagonal, and since it says it is 60 meters more, we'll say x plus 60. It says this is the length and it says 30 meters more, we'll say x plus 30. Now this is again a right triangle between the diagonal, the length and the breadth. So we can say that h square again is equal to p square plus the base squared. So h is x plus 60 whole squared is equal to the perpendicular squared and then the base squared. So we'll get x square plus 3600 plus 120 x is equal to x square plus again from here we get x square plus 900 plus 60 x. We'll cancel out x squared both sides and then we'll bring all the terms to one side. We'll get x squared minus 60x plus 2700 is equal to 0. Now again we have to divide minus 60 into two parts such that the product, this will be minus 2700 since this becomes minus. So the product should be minus 2700. So I'll write minus 90x plus 30x minus 2700. Since 90 into 30 is 2700 and plus into minus the coefficients, the sign will be minus. So I take x as common here, I get x minus 90. Then I take 30 as common, I get x minus 90. Which means that x plus 30 into x minus 90 is equal to 0. So either x is equal to minus 30 or x is equal to 90. Again, we are talking about geometric figures and the lengths cannot be negative values. This is a solution for the given equation, but it does not satisfy our need. So we will take excuse me, 90 as the correct answer. So we will say the dimensions are, since breadth was x, it is 90 meters. The length was x plus 30, so we'll say 120 meters. And the diagonal, which was x plus 60, will be 150 meters. So this is how we form equations and solve them from problems based on geometric figures. Now let's see the next type of problem that is based on speed, distance and time. So now let's look into problems that are based on speed, distance and time. To solve such problems, it is very important to stay true to your physics roots. That is, you must always remember, just a second, change this to the pen. Yeah. So we must always remember this relation that speed is always equal to distance over time. If we remember this basic relationship, solving this problem should not be a very big deal. Given that we understand what we are taking, yani the measurements that we are taking, or the unknown that the x we are going to take or y we are going to take in the equation represents what based on this relationship of speed, distance and time. For example, look at this problem here. It says by increasing the speed of a car by 10 km per hour, the time of the journey for a distance of 72 kilometers is reduced by 36 minutes. Find the original speed of the car. So let us see, how can we form an equation? We have to find the original speed. So we'll take, let the original speed be x. Then the new speed will be, since it says it's 10 kilometers per hour increasing, so x plus 10 kilometers per hour. How do we form an equation based on this? Just as I said, speed is equal to distance by time. Time is equal to distance by speed. Now here you have to understand that if it is taking a speed of x and a speed greater than x, when we are taking speed as the denominator, then when you divide it by x, that fraction is going to be larger, which means the time will be taken more when the speed is less, right? And then it says the time of the journey is reduced by 36 minutes. So what it means is the total distance is 72. Since the original speed was x, we subtract 72 by x plus 10. Now here you have to understand that since we are taking the time in x, that is kilometers per hour, and the time difference given to us is in 36 minutes, we must also convert it to a similar unit, that is hours. Since we did 36 by 60, it becomes hour, and this becomes 6 by 10. Then what we will do is, we'll take the LCM, x into x plus 10, multiply 72 x plus 10 minus 72 into x is equal to 6 by 10. 72x plus 720 minus 72x by x square plus 10x is equal to 6 by 10. 72x and 72x get cancelled out. We multiply 10 up here, we get 7200 is equal to 6x square plus 60x. Now we see we can divide this entire equation by 6. So we'll get 6 into 72 1200 is equal to x square plus 10x. So this is how we will form the equation. We bring it all to one side and it becomes x square plus 10x minus 1200 is equal to 0. This is how we will form an equation from a word problem given on speed, distance and time. Let's see a few more examples. So the next example is that car A travels x kilometer for every liter of petrol, while car B travels x plus 5 kilometer for every liter of petrol. So now it says write down the number of liters of petrol used by car A and car B in the covering a distance of 400 kilometers. We know that fuel economy can be given by number of kilometers run divided by the number of liters of fuel used. So the fuel economy of A, that is we can say so in that sense it will become that if we have to find out the number of liters, not the fuel economy, sorry, the number of liters, it will become the number of kilometers total run divided by that fuel economy, that is the number of kilometers the car runs per kilometer. For A, that fuel economy is given as x kilometers. So we'll see that the number of liters will become number of kilometers, that is 400 by x. Similarly, for B, this relation, since it is given that B travels x plus 5 kilometers, the fuel economy is x plus 5. So the number of liters of fuel used by B will be 400 by x plus 5. This is that we gave the fuel consumption of both the cars. Now it says if a car A uses 4 liters of petrol more than car B, then write down an equation, which means that the petrol used by A is equal to the petrol used by B plus 5 kilometers. We bring this term to the other side, we get 400 by x minus 400 by x plus 5 is equal to 5. Then we take the LCM, we go 400 into x plus 5 minus 400 into x by x into x plus 5 is equal to 5. So this will become, since x and 400, when I multiply it becomes minus, so it becomes 2000 is equal to 5x square plus 25x. I divide the equation by 5. So I'll get x square plus 5x, and I'll bring 200 to the other side, divided by 5, it becomes 40 minus 40 is equal to 0. So this will be the relation to find the value of x. Now that we have understood how to form equations based off of problems of speed, distance and time, let's try and solve a few problems. Okay. First question says a car covers a distance of 400 kilometers at a certain speed. I'm sorry, I wrote distance by mistake. This should be, had the speed been 12 km per hour more, the time taken for the journey would have been 1 hour 40 minutes less. Find the original speed of the car. So we are supposed to find the original speed of the car, which is not given to us. So basically that is the unknown. So let us say, let the original speed be speed original, which is x km per hour. So now the new speed or the change speed that the question is talking about is x plus 12 km per hour. Based off of this, if speed is equal to distance by time, that means time is equal to distance by speed. So the time taken originally would have been the distance, that is 400 by x, that is the speed. And the new time taken should have been 400 by x plus 12. Now it says that the difference between these two times is 1 hour and 40 minutes. Which means we should understand that if this denominator is x and this denominator is larger, that is x plus 12, it means that this time would be taken more. And it makes sense, if the speed is less, the time taken would be more. So we'll say TO minus TN is equal to 1 hour 40 minutes, which is 40 by 60 hours. So we cut this off and we get 2 by 3. So now we'll feed the values into the equation. TO is 400 by x minus 400 by x plus 12, which is equal to 5 by 3. Since this is 1, 2 by 3, it becomes 5 by 3. Now we'll say x into x plus 12. Here we'll write 400 into x plus 12 minus 400 x is equal to 5 by 3. So 400x plus 4800 minus 400x by x square plus 12x is equal to 5 by 3. 400 and 400 get cancelled out. So we can multiply this, divide this 4800 by 5 directly, we'll get 960. So multiplying 3 here and this here, we'll get x square plus 12x is equal to 2880. 2880. Yeah, 2880. And then x square plus 12x minus 2880 is equal to 0. Now solving, if we solve this quadratic equation, we will get the speed of the car, the original speed of the car. So let's try. So this here is 2880 and we have 12. If I factorize, I need to get minus 2880. Yeah, I can write 60x minus 48x minus 2880. So I'll take x as common, I'll get x plus 60, and then I'll take minus 48 as common. And again I'll get x plus 60. So x minus 48 into x plus 60 is equal to 0. Which means x is either equal to 48 or x is equal to minus 60. Now since the x that we took was a speed, it cannot be negative. Since the car is moving forward, it's not deceleration, we know. So this speed cannot be negative. So the original speed of the car was 48 kilometers per hour. Not was, is 48 kilometers per hour. So let's see a few more example questions. So the next question says a plane left 30 minutes later than the scheduled time And in order to reach its destination 1500 kilometers away in time, it has to increase its speed by 250 km from hour from its usual speed. So find its usual speed. Again, we'll take the usual speed to be the unknown. So let the usual speed SU be x kilometers per hour. So the new speed Sn is equal to x plus 250. Now the question is trying to explain that this plane did not reach early. Instead, it started late, but the time difference is the same. That is, there's a difference in the time between both the cases. If the plane was flying with a speed of x kilometers per hour, the time would be 1500 by x. Similarly, when it started traveling by x plus 250, that is the new time, it was 1500 by x plus 250. And the difference between these two times was 30 minutes. So, the difference between the original time and the new time is 30 minutes, that is 30 by 60 hours, which becomes 1 by 2. Now again, just to feed the values into this, I'll get 1500 by x minus 1500 by x plus 250 is equal to 1 by 2. So x into x plus 250, 1500 into x plus 250 minus 1500 x is equal to 1 by 2. So 1500 x plus 250 into 1500 minus 1500 x by x square plus 250 x. This and this gets cancelled out, and this is equal to 1 by 2. We multiply it, it becomes 500. 2 becomes here, and this is 500 into 1500 will be 5 into 15 is 75 is equal to x square plus 250 x. So we'll write x square plus 250 x minus 75 or 7,50,000 is equal to 0. Now we'll solve this equation to find the original speed of the plane. So since it is 7,50,000, we need to do so we'll write it as x square plus 1000x minus 750x minus 7,50,000 is equal to 0. Taking excess common, we get x plus 1000 minus taking 750 as common, we again get x plus 1000. So x plus 1000 into x minus 750 is equal to 0, which means x is either equal to minus 1000 or x is equal to 750. Now since we are talking about speed, that is we took the variable to be a speed, we know that it can't be minus 1000. So the speed has to be 750. So the speed of the plane was 750 kilometers per hour. So this is how we can solve problems based off of problems, that is word problems related to speed, distance and time. Now let us see a few miscellaneous word problems that will pop up in the chapter of quadratic equations. These problems can be related to sales, that is discounts, profit and loss, or they could be related to some random experiment, or they can be about upstream and downstream questions. So we'll see a few of these examples and try to solve equations off of them. So see, the first one says, by selling an article for 24, a trader loses as much percent as the cost price of the article. Okay. So nothing to us is given here except that the selling price is rupees 24 and it says that he loses as much percent as the cost price. Let us say the cost price is x. So the loss will be x minus 24. Now we know that the loss percentage can be calculated as x minus 24, that is the loss divided by the CP into 100. This will give us the loss percentage, and the question says a trader loses as much percent as the cost price, which is equal to x. Now if we bring this x to the other side, the equation becomes x minus 24 into 100 equal to x squared. Is 100x minus 2400 is equal to x squared. Bringing all to the other side, we get x squared minus 100x plus 2400 is equal to 0. This will be how we are supposed to form an equation from a miscellaneous problem. That is, this one is based on profit, loss and discount. Let us see one more example. So now there's another type of problem that says 2-digit numbers. So in 2-digit number problems, you'll having a 2-digit number and the relation will be between the digits of the number. So it says a 2-digit number is such that the product of its digit is 6. When 9 is added to this number, the digits interchange place. Let us see. If we have a number, 2-digit number, it has a 1's digit and a 10's digit. Let us say the first number is x. Now since it says the product of the numbers is 6, let us say the next number is 6 by x. Since multiplying both of them, we'll get 6. What will the reverse of this number be? The reverse will be 6 by x will be in this digit and x will be here. Now you have to understand that these are not numbers themselves, they are digits. So when I have to take out the place value, that is I'm supposed to write the actual value of each digit. How do I write it? In earlier classes we used to do. So this would be equal to, since it's in the 10th place, we'll say 6 by x into 10 plus x into 1. This is the number. That is the original number. And the second number will become x into 10 plus 6 by x. So these are the actual values of both the numbers. Now this says that 9 is added to this number. That means when I add 9 to this, we get this. So we'll write 60 by x plus 9, since I have to add 9, is equal to 10x by 6 plus 6 by x. So what I'll do is I'll bring all the terms to one side. I'll get 10x minus x plus 6 by x minus 60 by x plus 9 is equal to 0. This becomes 9x minus 54 by x plus 9 is equal to 0. So I take the LCM as x. So I get 9x squared minus 54 plus 9x is equal to 0. So I can write 9x squared. Taking x to this side, I get 9x squared. 54 plus 9x is equal to 0. When I divide the entire equation by 9, I get x squared plus x minus 6 is equal to 0. So from this given statement, we formed the equation x squared plus x minus 6 is equal to 0. And that is how we will be forming equations based off of these miscellaneous problems. Let us see one more. So it says 5 years ago, a woman's age was the square of a son's age. 10 years hence, her age will be twice that of a son's age. Just to remember, it says 5 years ago. Let us start originally by taking 5 years ago itself, because it gives us a clear relation between their ages. It says that a woman's age was the square of her son's age. Let the son's age be x. 5 years ago. So now the mother's age is x squared, right? It says it's the square of her son's age. 10 years hence. Now since this is 5 years ago and this is 10 years from the present time, it means it is 15 years later, right? So 15 years later, first of all, their ages will be x plus 15 and x squared plus 15, right? Now it says 10 years hence, find the present age of the woman. To form this equation, we need to understand, it says that 10 years hence, her age is twice that of her. So 10 years, that is here, it is x squared plus 15 is equal to 10 into x plus 15. So I get x squared plus 15 is equal to 10x plus 150. Bringing all to one side, I get x squared minus 10x minus 135 is equal to 0. So from this given statement, this is how I formed an equation. So now that we have understood a bit about miscellaneous problems, let us try and see a few example problems and solve them for ourselves. Now that you have understood how to form equations based off of miscellaneous word problems, let's try and solve a few examples. First one says a stone is thrown directly downwards and the formula d is equal to 16t square plus 4t gives the distance d meters in falls in t seconds. So this relation that is given d is equal to 16t square plus 4t is between d and t, where d is the distance and t is the time taken. So how long does it take to fall? 420 meters, which means the distance is given as 420 meters. Now we know that the formula is d is equal to 16t square plus 4t. So we'll just put d, that is 420 is equal to 16t square plus 4t. t a bit differently so it doesn't look like a plus. So we'll divide this entire equation by 4. We'll get 105 is equal to 4t square plus t. And bringing t this to the other side, we'll get 4t square plus t minus 105 is equal to 0. So now we have 4 into minus 105, that is minus 420. So we have to find two numbers such that add up to 1, because here the coefficient of t is 1, and multiply to form minus 420. So we'll just prime factorize 420 once. Yeah. So we'll take it as 4t square plus 21t minus 20t minus 105. So yeah, I can take nothing common except as t. So I'll take 4t plus 21. Then I do minus 20, I get the same. Sorry, I'll take minus 5 to get 4t plus 20. So t minus 5 into 4t plus 21 is equal to 0. So t is either equal to 5 or t is equal to 21 by, sorry, minus 21 by 4. Now since the t we considered was the time, it cannot be negative. So the time taken will be 5 seconds. Okay, students, with me so far? Okay, let's see one more example problem. Now this one says the speed of a boat in still water is 15 kilometers per hour. It can go 30 kilometers upstream and return downstream in 4 hours 30 minutes. Find the speed of the stream. Now to understand here, that in still water, a boat can run normally. But if the river or a stream is running in one direction, it means it has some speed. Let us say the speed that we don't know here is x. So when the boat is running in direction of the stream, it has its own speed and also the stream is pushing it with this x speed. So the speed going upstream, that is speed upstream, will be 15 plus x kilometers per hour. However, when the boat is going back, it is working against the speed of the stream. So it becomes, the speed of the downstream becomes 15 minus x. Get the point? And this distance is 30 kilometers. One journey is upwards, one journey is downwards. Let us try and form an equation first based off of the information. It says it can go upstream and return downstream. It means you have to calculate the time of both. So the time for the upstream is the total distance, that is 30 divided by the speed. Similarly, the time for the downstream is 30 divided by the speed. Now it says that these two times added is equal to 4 hours 30 minutes, which is nothing but 4.5 hours. So we can say that 30 by 15 plus x plus 30 by 15 minus x is equal to 41 by 2. Okay. Now we'll take the LCM here as 15 plus x into 15 minus x, which will become a plus b into a minus b is a square minus b square. So 30 into 15, sorry, minus x, and plus 30 into 15 plus x, which is equal to 9 by 2. So I'll get 450 minus 30x plus 450 plus 30x, sorry, divided by 225 minus x square is equal to 9 by 2. Since 30 and 30 get cancelled out, this becomes 900 by 225 minus x square is equal to 9 by 2. Cancel this out as 100. The equation I get is 225 minus x square is equal to 200, which means minus x square is equal to minus 25. So x square is equal to 25. Here we don't have an equation as such, we just have to substitute the value of x. So we know that we can take the root, which will be root over of 25. But it will not be the same root, it will be plus and minus, because minus 5 squared is also 25. So x will be equal to plus or minus 5, which means x is either equal to 5 or x is equal to minus 5. Now we know that the x that we took was the speed of the stream. So it's the speed, it cannot be negative. So the speed of the stream is 5 kilometers per hour. This is how we can solve problems based on speed of a a boat and a stream considered together. Okay, let's see one more example problem. It says the product of the digits of two numbers is 24. If its unit digit exceeds twice its 10th digit by 2, find the number. The first thing that we need to do is its unit digit exceeds the 10th digit. So let's say let the 10th digit be x. So we know now that the units digit is what? It is twice the 10th digit, that is 2 into x plus 2. It exceeds, so we add plus 2. Now the first part of the question gives us the relation that will give us the equation. It says product of the digits is equal to 24. So now that we know the digits, we'll just multiply them. X into 2x plus 2 is equal to 24. So we'll get 2x squared plus 2x is equal to 24. If we can divide by 2, we get x square plus x is equal to 12. So x square plus x minus 12 is equal to 0. Now we'll start solving. So I have to bring coefficients that will add up to 1 and multiply to form minus 12. So that 4x minus 3x minus 12 is equal to 0. So x to x plus 4 minus 3 into x plus 4. X minus 3 into x plus 4 is equal to 0. Which means x is either equal to 3 or x is equal to 4. Now it says it's a 2-digit number. Minus 4. And the digit cannot be minus 4. Obviously, right? So the digits will be, here it will be 3. And since this is 2 into 3 plus 2, this will become 8. So the number is 38. So now let's see one last example. It says rupees 6500 was divided equally among a certain number of persons. Had there been 15 persons more, each would have got rupees 30 less. Find the original number of persons. So we'll take, let the original number of people be x. So the new number of people is, there is a special case that is shown is x plus 15. Now here you need to understand, if we have more people and the amount of money is same, which means that in this case, that it is the second case, people will get lesser money, which is clear from the question itself. So now how much did each get? So each share original would have been 6500 by x, right? And each share new would be 6500 by x plus 15. Now according to the question, it says that this difference is equal to 30 bucks. Let's try and solve it. Into x plus 15, 6500 into x plus 15 minus 6500 into x equal to 30. 6500 x plus So now let's see if we can divide this. So yeah, we can, and then we'll divide this by 3. We will get 3250. So we have x square plus 15x is equal to 3250. It becomes x square plus 15x minus 3250. So now we have to solve it to get the value of x. So we'll do 3250. 2 will be 1625. 5 it will get 3, 2, 5. 5 will get 6. And I have to form 15, right? This is 45. Oh, 65 minus 50. So we'll write plus 65x minus 50x minus 3250 is equal to 0. Here I take x's common, I get x plus 65, and here I take minus 50s common, I get x plus 65. So x minus 50 into x plus 65 is equal to 0. So x is either equal to 50 or x is equal to 60 minus 65. Since the x that we were considering was the number of people, it cannot be negative. So the number of people was 50. So this is how we can form word equations, that is form equations, quadratic equations from given statements in word problems. And then we can solve the different type of problems as we saw. So here we have come to the end of our lesson today. This was just a conceptual video, that is to understand how to approach this particular chapter of word problems on quadratic equations. So please stay tuned to the channel as we'll be bringing an exercise solving session very soon. Apart from that, please subscribe to our channel and join the Mudha Guru family today. Until then, I'll see you next time.